Self-practice 5.7, question 3. A squared paper is cut into 4 equal-sized squares. Okay, we have a square paper. We cut this paper into 4 equal squares. So we have 1, 2, 3, 4. Okay. Then each portion is then cut again into 4 smaller equal-sized portions. So each portion is cut into 4 squares, 4 squares, 4 squares, and 4 squares. Now we have 16 squares. 1, 2, 3, 4. 1, 2, 3, 4. So we have 16. Okay. This process is repeated on each small portion square. So they cut it into 4 again and so on. Show that the number of squares cut forms a geometric progression. Okay, so initially we had 1 square, then we cut it into 4, and then we have 16 and so on. So we need to show this is a geometric progression. Okay, to show if it's a geometric progression, we must make sure the R is the same. The R must be constant throughout. Okay, so the formula for R is T2 over T1, or T3 over T2, or T4 over T3, and so on. So if our T2 over T1, the answer, is equal to this answer, that means it's a geometric progression. So let's find the first R. T2 over T1, we have 4 over 1, which is 4. Okay, and then we find the other R, T3 over T2. So T3 is 16, T2 is 4, 16 over 4. 16 over 4 is also 4. So since the R's are the same, this is a geometric progression. Done. Shown. Okay. Next. So we can update this. We can say R is 2. R is 4. Right. Let's try B. Find the total squares obtained if the process is repeated 6 times. Okay. So the first time, let me erase this. Okay, the first time we only have 1 square. Okay, this is our T1. And then this is the T2. T2 we have 1, 2, 3, 4, and the big square is another one. So we have 5 squares. So after dividing it by 4, in total we have 5 squares. Then we divided it some more to get 16 boxes. Now we will have the original 5 squares, 1, 2, 3, 4, 5, and then we have extra 16 squares inside. Okay, what I'm trying to say is, if you want to find the total squares after repeating 6 times, we must find S6, not T6, because after repeating it for 6 times, we are going to get the sum of all these squares, because the original squares didn't go missing. We just adding more squares. So the original 4 squares plus the 1 didn't go missing when we got 16. We just added lah. Long story short, we just need to find S6. Right. So the formula for S6 is A Rn minus 1 over R minus 1. Our A is the first term, R is 4, 4 minus 1. So 4 to the power of 6 minus 1 divided by 4 minus 1, which is 3. We get 1365 squares. Okay, so most students will get confused whether to use Tn or Sn. Here we need to use Sn because we are adding the previous squares. The previous squares did not go missing. So every time we divide it, we are just adding more and more squares.